most important topics in cracking JEE as well as NEET are graphs, and that is exactly what we are going to see today in this particular lecture. Welcome to Diksha Vedantu everyone, and welcome to the series Titans, and welcome Titans on the channel Diksha Vedantu. Now in this particular chapter we are going to see the first and the foremost important topic, that is graphs. Now it's not just about motion, this is just the starting. Graph is a very deep topic. Even if you go into computer science engineering or mechanical engineering or electrical engineering, everywhere you will get graphs, and these are the basic topic for that particular this is the foundation for that particular topics, correct? So get ready and be with me till the last of the video, because you are going to learn so much from this, and we are going to see some actual JEE and NEET questions in this video. Okay, now before that beta, in the last lecture we studied about units and measurements. So we saw the basics about units as well as dimensions, which are again a very important topic. Now this dimension is just not singular topic. Okay, in every particular chapter you will be coming back to dimensions, so it's very important. If you have not watched it, go back, watch that chapter again, watch that first lecture again, and then come back to this particular one. Now starting with the very first beta, let's see about the basics first. Now in the motion chapter, if you are in 9th class, you must remember. If you are in 10th, however, let's recall it a little bit. Okay, what did we study? Ma'am, we studied two kinds of things. First was a scalar quantity and second was a vector quantity, correct? Scalar quantity, vector quantity. Scalar had only and only magnitude, and vector had what? Magnitude plus direction. Ma'am, this is simple, we all know it. Very good. Now beta, after that, what were the quantities we studied in the motion chapter that were scalar or vector? What were those? Ma'am, scalar we studied about distance, the total path covered. The total path covered, I am going 2 steps, I come back 3 steps, I come back again 4 steps, total steps 9. But I started from this and now I'm finally 1 step here, or I was 1 step here, right? So the displacement is what? 1 step in the left direction, that is displacement. Distance is what? 7 steps, 9 steps. So that's the difference, right? So we studied that displacement is a vector quantity and distance is a scalar quantity. And from that we studied that distance per unit time. Distance per unit time is then, ma'am, speed, which is also a scalar quantity. Displacement per unit time, ma'am, is then velocity, which again is a vector quantity. And then we studied lot more, that is your force, your acceleration, all those are what? All those were vector quantities. Done. That's the basic of scalar and vector. Now this can be positive, negative or 0. This can only be either 0 or positive. It can be either 0 or positive, and similar to that goes for distance and speed and displacement and velocity as well. Now beta, when we move a little bit further, we talk about speed, we talk about velocity, we talk about average speed. What is the average speed? What is average speed? Now this is one of the basic and important things, which is what? Ma'am, total distance covered per unit total time in total time. So even if I took a break of 10 minutes, I will count that time in 10 minutes. Okay, I will count that 10 minutes in the time. Okay, so that's basic of our scalar and vector. After that beta, after that again a very important thing comes. You go to school. Okay, you go in a bus, your bus takes you and then your friend, then it picks up another friend, then some any other friends, and you finally reach to school. Now what kind of motion this is? What kind of motion this is? What kind of motion this is? Come on, recall, remember. Now, beta, we studied about two motions. First is uniform motion and the second one is what? Non-uniform motion. Second one was non-uniform motion. Uniform motion, what did we have? Ma'am, the bus traveled to first C and then B. So, it traveled how much? 25 meters in 10 seconds. But in next 10 seconds, it only traveled what? 10 meters in 10 seconds. So, it is traveling, wait a second, 10 seconds. It is traveling unequal distance in equal amount of time. Unequal distance, 25 meter, 10 meter, not equal. In equal amount of time, 10 second, equal, right? So, that is your non-uniform motion. That is unequal distance in equal interval of time. Equal interval of time. That is your non-uniform motion. Now, if I would have said that no, it just traveled first 20 meter in 10 seconds and then next 20 meter in again 10 seconds. Right? Next 20 meter in again 10 seconds. So, it is traveling what? Equal distance in equal amount of time. That is what? Your uniform motion. It is equal distance in equal amount of time. Equal interval, we call it interval, not amount. Okay? Equal interval of time. That is clear. So, uniform motion is equal distance in equal interval of time. Non-uniform motion is unequal distance in equal interval of time. Then we will study about uniformly accelerated motion. What is that? Wait for some time. Okay. Now, beta, moving on to the graphs. So, the very first graphical representation we are going to see is distance time graph, or we can also call it, let's not call it distance because it gives a false idea that this is only distance and not displacement. You guys were commenting on the last video which I made for 9th class. Okay, so it is not displacement time graph, it is position time graph. Position time graph. Okay, that makes clear. Now beta, see this very carefully. Now at rest, I am not moving. So is my position changing? No ma'am, it's not changing. But let's say this is zero coordinates. Okay, so my position is not changing. But I go and I stand at 10 meters, but now also I'm not moving. So is my position changing? No, my position is not changing. So I was at rest when I was at zero coordinates. I am also at rest when I am at 10 meters, right? So that means time is passing by. 1 second, 2 second, 3 second, 4 Mississippi, 5 Mississippi, 6 Mississippi. Time is passing, but I am not moving. That means, look at this carefully, why this graph? Now, at rest beta, see, distance is the same. This is distance, okay, in meters. This is time in x-axis, distance in y-axis, okay. Time will always be in x-axis. Now beta, 10 meter, 1 second, also 10 meter, 2 second, also 10 meter, 3 second, also 10 meter. That means I am at rest. Distance is not changing, but time is changing. Distance is not changing, but time is changing. Understood? Next. Now coming to uniform motion. What is uniform motion? See, understand this first. When we talk about uniform motion, we said equal distance or displacement, in equal interval of time. Equal interval of time, right? So that means, see, the object started from 0 second, 0 meters. It goes to 10 meters in 1 second. Then another 10 meter in another second. Another 10 meter in 2 to 3 second. 30 to 40 meter in 3 to 4 second. So it is traveling 10 meters in 1 second. 10 meter in 1 second. 10 meter in 1 second, 10 meter in 1 second, 10 meter in 1 second. So equal distance in equal interval of time, right? So its graph will be a straight line. Its graph will be beta a straight line. Understood? Understood this graph? Why we made this? Because it is traveling 0 to 10, 10 meters in 0 to 1 second, 10 to 20, 10 meters in 1 to 2, 1 second, 20 to 30, 10 meters in 2 to 3, 1 second, 30 to 40, 10 meter in 3 to 4, 1 second. Done. So it is traveling 10 meters in 1 second. Understood? Clear? Clear? Now look at this graph. This graph is very bad. What is this? It is starting from 0. In 1 second, it reached at 10 meters. In 1 second, it reached at 10 meters. Understood? In next 1 second, it didn't even move. It didn't even move. It stayed at 10 seconds. And then in the 2 to 3 second, it speed up and reached to 40 meters. First, it was traveled only 10 meters in 1 second. Then 0 meter in 1 second. Then 30 meters in 1 second. So the distance is unequal. So we have unequal distance, right? Unequal distance or beta displacement in equal interval of time. In equal interval of time. 1 second, 1 second, 1 second. In this 2 to 3, then this 1 second it traveled 30 meters. So that is not true. So it will not be a straight line. It will not be a straight line. Are you understanding how we are making these graphs? We kept time on the x-axis. Now beta, there is a very good thing. It's a little bit of high level, but if you know, you'll understand. I learned it in my graduation. So what happens? How do we know? Why did I not take distance on x-axis and time on y-axis? That's a really good question. So what we do is, on the x-axis, we take something that is not a dependent quantity. What did I say? We take something that is not a dependent quantity. This is your graph. So we take on the x-axis, we take something that is not a dependent quantity. Now time does not depend on anything. It will move forward anyhow. If the earth bursts today, sun go out, moon falls on the earth, it will still keep on going with 1 second, 2 second, 3 second. So it does not depend on anything in this world. So that's why a quantity which is independent will be on the x-axis. Now distance, ma'am, how is distance dependent? It's not actually dependent, but still time is more independent than distance. Time will never stop. But with the time, distance can change. With the time, distance can change. Okay, it cannot change, it can change. It has a willpower. I will not drive the car today. So even the time is going out, my car is still in the home, right? So that means distance can be 0, can be negative, can be displacement can be negative, distance can't be negative. But we have a choice over the distance, but not over the time. So time is independent, distance is a willpower, a choice, right? So then independent quantity will be at x-axis, a dependent quantity will be on y-axis. Done? Great. So this was beta position time graph. Understood everything? If you have any doubt, let me know in the comment section. Now let's move on to velocity time graph. What it is? Velocity time graph. Now beta, talking about velocity time graph, we again have very first thing, that is at rest. Now I am not moving. Velocity is what? Displacement upon time. Velocity is what? Displacement upon time. That means how much path I am covering in a particular time. So time is going by 1 second, 2 second, 3 second. I'm not even going somewhere. I'm not even going anywhere. So displacement is what? 0. So velocity will be what? My speed, my velocity, it is what? It is 0, ma'am, because you are not even moving. So velocity is always 0 at rest. See, in this position time, it had some position coordinates, okay? It is distance or displacement. So this is 10 meter. So even at 10 meter, I am at rest, but I am at 10 meter. In velocity, can I say my velocity is 30 meter per second? My car is moving at 30 meter per second, but it is at rest. Can I say that? No, I can't say that. If your car is at rest, its velocity or speed will be 0. right? Always. So for rest beta, the velocity or speed will always be 0, that is on x-axis. It will be on x-axis. So here write on x-axis. So the graph of velocity with respect to time will be on x-axis for rest. That's done. Understood? Now beta, talking about uniform motion. Again, uniform motion was what? Equal distance in equal interval of time, right? Now come back to this particular thing. Let me make this again, okay? Understand this very carefully. Understand this very carefully. Now beta, this is your velocity time graph, okay? This is your velocity time graph, and this is the, okay, this was what? This was displacement time graph. Displacement, or let me write position time graph, and this is your uniform motion, equal displacement in equal interval of time, 10, 20, 30, 40, and this is 1, 2, 3, 4. Now you tell me, let us find the velocity. Velocity will be what? Displacement upon time, right? So velocity will be displacement upon time. Let me find the displacement between 0 to 1 second. 0 to 1 second, what is the velocity? Velocity, what will be the velocity? Ma'am, displacement 0 to 10 meter. So displacement is 10 meter divided by 0 to 1 second. 1 second. So velocity will be 10 meter per second. Understood? Then ma'am, let's find the velocity of 1 to 2 second. Velocity of 1 to 2 second. Okay. Now ma'am, velocity will be what? Displacement. I am going from 1 to 2. Okay. So final position is 2, initial is 1. So velocity will be what? Change in position, right? Change in position is 2 minus 1. Final position minus initial position. Divide by final. Oh, I wrote time. Okay. Maafi. Position. So in this 1 to 2 second, now I'm already at 10. Okay. From 0 to 1 second, I traveled from 0 to 10 meter. Now I am at 10 meter and at 1 second. So in the next 1 second, I go from 10 to 20 meter. Okay. So this is final position and this is initial position, right? So final position is what? 20 minus initial position is what? 10 divided by interval of time. So final time is what? 2 minus initial time is what? 10. So this will be what? 10 divided by 1, again 10 meter per second. Now, okay ma'am, that can be a coincidence. Let's do for 2 to 3 second. Okay, 2 to 3 second. Now ma'am, in 2 to 3 second, I went from 20 to 30 meter. So final position is 30, initial position is 20 divided by final time is 3, initial time is 2, and this is our velocity. So velocity is what? 30 minus 20, 10, 3 minus 2, 1. So velocity is 10 meter per second. That means in uniform motion, this was what? It was a uniform motion, right? So for uniform motion, your displacement is changing, your time is changing, but velocity is not changing. 10 meter per second, 10 meter per second, 10 meter per second. So your velocity is not even changing. That means the graph, that means beta, see, velocity is 10 meter per second. For 0 to 1 second, velocity is 10 meter. 1 to 2 second, velocity is 10 meter. 2 to 3 second, velocity is 10 meter per second. So graph of velocity with the time will be what? Time is going on. 0, 1, 2, 3, and this is your velocity. Velocity was what? 10. It was 10 at 0 second, it was 10 at 1 second, 10 at 2 second, 10 at 3 second. So this will be your final graph of velocity with respect to time. Understood? Velocity with respect to time. Done? That is our final graph. See, velocity is 20 meter per second at 0 second, 20 meter per second at 1 second, 20 at 2 second, 20 at 3 second, 20 at 4 second. So it is uniform motion. So remember one thing, that in uniform motion, your velocity will be constant. Your velocity will be constant. We also call it constant velocity. Of course we do, but constant velocity. Understood? Clear? This part is clear? Very important. This is very important. These are the small things that will make you learn graphs in future. It is very important. Graphs are the most important topic of this whole chapter, of this whole NEET and JEE syllabus. Okay, so pay attention here. Now, non-uniform motion. What was non-uniform motion? Unequal distance in equal interval of time. That means, see, here the velocity is what? Displacement upon time. So 10 upon 1, make, go a little faster, okay, with me. So this is velocity upon, displacement upon time, 10 by 1. Velocity is 10 meter per second. In this is here, the displacement is 0. Velocity is 0 meter per second. Then 2 to 3 second. Velocity is what? Displacement upon time. Displacement is what? 30. And velocity and time is only 1. So velocity is displacement upon time. 30 upon 1 second. 30 meter per second. So velocity is what? 10 meter per second. 0 meter per second. 30 meter per second. That's insane. Velocity is, let me draw this again. Velocity is what? First 10 meter per second, 0 meter per second, and then 30 meter per second at third second. So what is the graph? The graph is something like this. Weird graph. It's going up, going down, going up again. So this is non-uniform motion, that our vehicle is not driving uniformly. It is changing its velocity. Sometime we apply a brake, so the bike goes to 0. Sometimes we speed up. You are doing a race with your friends, which you shouldn't. You are not even legally 18, right? So you shouldn't. Now, your elder brother is doing some race with his friends, okay, or your elder sister for that matter. So they are like speeding up. So now they are traveling at 40 kilometer per second or 40 meter per second. But there is a kid came in front of them and they apply a brake. Now they are at rest. They are at 0 meter per second. And then your mother comes and give a tuckly and they are now running with 100 kilometer per second. Okay, so beta, that's the point. Your velocity keeps on changing when we go to market. When you even go to get a burger, let's say, you will go, you will see a red light, you will stop, you will see a green light, you will again accelerate, and then you will be traveling at 30 meter per second, then again brake 0 meter per second, then empty road 50 meter per second. So all of these is what? A non-uniform motion, that is unequal distance in equal interval of time. UDET, unequal distance in equal interval of time. This is what? EDET, equal distance in equal interval of time. If you want to remember like this, EDET, UDET. Okay, then in this beta we have 2 more cases. And that is what? That is your uniform acceleration. Acceleration in velocity time graph. Yes, look at this carefully. Now before that, let's see what actually is acceleration. Right? Now what was acceleration? This mic, oof, I was about to fall. Okay, so acceleration beta is what? Acceleration is change in velocity per unit time or divide by change in time. Is this color okay? Should I change the color? It's okay. Okay, I'll change the color, but okay. So beta, what is happening? This is final velocity v minus initial velocity u divided by time. This is your acceleration. Okay, this is your acceleration. Now go back to this graph. Now come into this. Uniform acceleration. Uniform acceleration means velocity is continuously increasing. In first second, velocity was 10 meter per second. In second velocity was 20 meter per second. In third second, velocity was 30 meter per second. In fourth second, velocity was 40 meter per second. So in every second, velocity is increasing. In every second, velocity is increasing. That means beta, first second 10 meter per per second. Second, 20 meter per second. Now this is velocity. Here beta, it was velocity, but it was constant for uniform motion. Changing, but unequally changing, right? But we were still thinking about displacement, right? Here we are talking about velocity. So velocity is changing, velocity is changing, velocity is changing, velocity is changing with the time. So this is uniform acceleration, that your velocity beta, it is not constant anymore, it is changing with respect to time. Okay, that means your acceleration is uniform. Now what do I mean by uniform acceleration? That is beta almost equal to acceleration is constant. Acceleration is constant. Ma'am, what do you mean by that? Now let's see that same graph again, that same graph, but now not position time, velocity time. Okay, so this is 10, 20, 30, 1, 2, 3. Okay, so acceleration is what? It is change in velocity, change in velocity per unit time. Per unit time. So let's see in the 0 to 1 second, 0 to 1 second, let's see the acceleration. Acceleration is, ma'am, final velocity minus initial velocity per unit time. We just saw it here, right? Final velocity, initial velocity per unit time. So here final velocity is what? In the 0 to 1 second, final velocity is what? 10 meter per second. This is meter per second. Okay. So this is 10 meter per second. Initial was what? 0. So this is 10 minus 0 divided by final time was 1. Initial time was 0. So this will be 10 meter per second square, because this is acceleration. Okay, then let's see 1 to 2 second. In 1 to 2 second, velocity is what? 1 to 2 second, velocity increased from 10 to 20. So final velocity is 20. This is acceleration. So final velocity is 20, initial velocity is 10, divided by final time is 2, initial time is 1. So this will be what? Acceleration is 20 minus 10, 10 meter per second square. Okay, let's do it for 2 to 3 second as well. Let's try. Acceleration is what? It went from 20 to 30. Velocity went from 20 meter per second to 30 meter per second. So final velocity 30 meter per second. Initial velocity 20 meter per second. Final time 3. Initial time 2. So acceleration is again 10 meter per second square. Now see, acceleration is not changing, is not changing, is not changing with the time. Time is changing, but acceleration is not changing. So we call it uniform acceleration. Uniform acceleration, that means velocity is changing, but acceleration beta is constant. So velocity is changing, but for this, if you make a graph of acceleration time, we will see it, but let's see it here as well. Acceleration time, so it will not change. What? It was 10, so it will be 10 at 1 second, 10 at 2 second, 10 at 3 seconds, so it will be simply like this. Acceleration time graph. Done. Then what is non-uniform acceleration? Velocity is changing, but it is decreasing, it is stopping somewhere. Just like again, you went with your father to have noodles, to have burgers, and he sped up, he is traveling at, in the first second, he reached the velocity till 20 meter per second. And then in the next second, he was like a little slow. So 20 to only 30 meter per second. 10 meter per second increase from first to 10, first to 1, wait, in the first second, the velocity was 20 meter per second. Okay, then from first to 2 second, the increase in velocity was simply 10 meter per second. Right? Then he saw the burger shop approaching. So he's like, he's decreasing the speed. He's decreasing the speed. Now in the next second, he suddenly applied brake, and he changed the velocity from 30 to directly 0. So the change in velocity was what? 30 meter per second. Right? And it is downward curve. Downward curve means the vehicle is increasing in speed, increasing in velocity. This is decreasing in velocity. So this is what? Increase in velocity. This is what? Decrease in velocity. Velocity into time. This is what? Increase in velocity. This is what? Decrease in velocity. So non-uniform acceleration, that means unequal change in velocity It means what? Unequal change in velocity in equal interval of time. Simply unequal change in velocity in equal interval of time. First second, second second, third second. First second 20 meter per second. Second second only 10 meter per second. Third second 30 meter per second, but negative. So this is non-uniform acceleration. Done. Now beta, this will be your acceleration increasing. The increasing graph will be your acceleration. The decreasing graph, however, will be your retardation. It will be your retardation. So when you increase the speed, you are accelerating the vehicle. When you decrease the speed, you are deaccelerating the vehicle, or retardation is happening inside the vehicle. That is, it is stopping. First is dum 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 dum. That's acceleration. What is deceleration? Dum 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 dum. You have to feel it. Feel the acceleration. Okay, that's the point. Now beta, moving on, we have some very important things to do. After all these graphs, the main thing we are studying these graphs is to get conclusions, is to find some terms. What are those terms? Let's see one by one. Now beta, when you move to this particular slide, this tells you acceleration using velocity time graph. Now what is this? See, we saw velocity time graph. Okay, and we saw one thing, that we could find acceleration from it. From the velocity time graph only, we found that it's a uniform acceleration. From the velocity time graph, it's a uniform acceleration, non-uniform acceleration from velocity time graph. So that means from velocity time graph and acceleration has some connection. We just have to find it. Okay, now beta, look at this very carefully. First, tell me the formula of acceleration. Ma'am, acceleration is simply change in velocity per unit time. Okay, that is true. So I can write acceleration equals to v minus u upon t. Correct. Now beta, remember the graph, the VT graph. What is this? For uniform acceleration, this graph is increasing, right? So I've made the same graph here, exactly same graph, VT, same graph. Now I'm just saying that it starts from 0 second, and it has a initial velocity of, let's say, 0. Initial velocity of 0, or you can write it as u as well. Initial velocity as u, final velocity is v, it reaches here. So final velocity is v, initial velocity here is u. Okay, initial time is 0 second, final time is t seconds. Done. So how will I write the slope? First understand what a slope is. So beta, slope of a graph. So what happens? This is your graph, okay, and this is your some curve in the graph. This we call it curve, okay, even though it's a straight line. Now beta, this angle theta, or this, for this graph, this will be the angle theta. For this graph, for this graph, this will be the angle theta. So all these are slopes. It has the slope theta 1. The 2 has the slope theta 2. The 3 has the slope theta 3. Understood? So all of the graphs have different slopes. Now, how will you calculate this slope? Beta, this will be equal to the y component. That means this component y component and this component x component. How high it is in the y direction divided by how far it is in the x direction. So slope will be y divided by x. That will be your slope. Okay, now come back to this. In this, if I have to find slope, what will I have to do? See, look carefully. Slope will be what? See, the y-axis. What are in the y-axis? Ma'am, final, this is v minus u. If I take it, let's just take u as 0. That means my vehicle is starting from rest. From rest, then initial velocity is 0. So don't take u, just take that it traveled with v velocity in a t interval of time. So slope is what? Y-axis divided by x-axis. Y-axis is what? Till here, y-axis is v divided by x-axis. Till here, I have reached here in time t. So this will be t. So slope is beta v by t. Done. Now, if I take u0 here, if I take u equals to 0, just like I took it here, I am also saying that I am starting from rest. So, acceleration will be what? V divided by t. Now, acceleration is v divided by t. Slope is also equal to v divided by t. That means acceleration, beta, acceleration, this acceleration equals to v by t, slope equals to v by t. So, acceleration is equal to slope. Right? So, acceleration equals to slope, but slope of what? Slope of which graph? VT graph. VT graph. Slope of VT graph. Done? Done. Okay, let's move on to the next topic, beta. So, basically what we understand from this particular thing that let me make it a little smaller. Yes, so basically we understand that if I have a VT graph, velocity time graph, I can find the acceleration by dividing the velocity with respect to time, by finding the slope. By finding the slope, slope is what? The y-axis divided by x-axis, v divided by t. Done? So that means acceleration using velocity time graph. Acceleration using velocity time graph, the using was what? Slope. So, slope of velocity time graph is equal to acceleration. Revise it with me. Slope of velocity time graph is acceleration. Plus, slope of velocity time graph is acceleration. Right? One more thing we have to do similarly is velocity using displacement time graph. Now, we studied displacement time graph, position time graph. Okay, so position time graph, distance time graph, displacement time graph, all are same. Don't worry. Okay, now beta velocity time graph, I have taken just any graph. Right? Now again do the same thing. What is the formula of velocity? You tell me. What is the formula of velocity? Ma'am, it is simply displacement upon time. It is simply displacement upon time, or we write it as change in position per unit time, which is equal. Okay, same thing. Now velocity is what? Displacement upon time. Understood? Now ma'am, look at this again. Let's try to find its slope. So, ma'am, its slope will be y-axis divided by x-axis, right? Y-axis divided by x-axis. This slope is really important. Remember this slope? How do we find the slope of a graph? Y-axis divided by x-axis. Now, this x-axis is time given. It is given, and y-axis is displacement. So, let me take this displacement as what do we take? D, and this time as what? T second. So y-axis is what? D divided by t. This is what, beta? This is slope. So slope equals to d by t, velocity equals to d by t. Can I combine these? So beta, velocity comes out to be, velocity v comes out to be, if I cancel d by t from comparing these two, comparing 1 and 2, velocity will be equal to the slope. It will be equal to the slope of which graph? VT graph. No, now it's not VT graph. Now it's displacement time graph. That means, or position time graph. You can write anything. Displacement time graph. So, slope of velocity time graph gives you acceleration, but slope of distance time graph is giving you velocity. That's the difference. So, if anybody tells you what's the slope of distance time graph? Velocity. What's the slope of velocity time graph? Acceleration. Okay, one more thing. Then we'll do the questions. Now, displacement from velocity time graph. Now, beta, we saw that slope of velocity time graph gives us acceleration. Now, see one more very interesting and beautiful thing. Now, I have this graph. This is velocity time graph. Okay, this is velocity time graph. Now, again, you tell me the formula of displacement, because we need to find displacement from velocity time graph. This is the same velocity time graph. Velocity time graph, from this graph we found acceleration. Acceleration is what? Slope of velocity time graph. What if I tell you find displacement using velocity time graph? So I was like, okay, let me do that. So I have this, this particular velocity. This is constant velocity, uniform motion, right? So beta, this is velocity time graph. Now you tell me what's the formula of displacement. Okay, ma'am, we don't study the formula of displacement. You have, look here. Velocity is what, beta? Velocity is displacement per unit time, right? So displacement is what? Simply displacement is what? It is simply this velocity into time, right? So this will be velocity into time, beta. It is equal to displacement. So this is the formula for displacement, right? Formula for displacement. Understood? Now ma'am, how do I relate these two? Okay, we have been finding slope. Let's just find slope and do it. So what will be the slope? Ma'am, what will be the slope of this? Its slope is just 0. Its slope is 0. Okay, so but displacement is, that means displacement is 0. Okay, calm down. Let's see how to do it. Okay, not jump to the conclusions. Now, if I have this graph, this graph, what will be the slope? The slope will be V by T. Okay, so the slope will be V by T. But ma'am, here displacement is V into T. So I can't write slope equals to displacement. Earlier we did what? Slope is equal to V by T. Acceleration is also V by T. That means acceleration is equal to slope. Simply means slope is equal to 6. Acceleration is also 6. So acceleration and slope are same, right? That's the thing. So we equated them. But here displacement is velocity into time. Multiply time. This is velocity divided by time. So I can't use slope. I can't say that displacement is equal to slope of velocity time graph. I can't say that. So what will I do? Here comes beta another very important concept, and that is area under the graph. Area under the graph means this whole area. Now what is this area? This is a rectangle. What is the area of rectangle? You tell me one. Area of rectangle, ma'am. Area of rectangle is simply length into breadth. Now ma'am, here length is time and breadth is what? Breadth is velocity. So it is V into T. So area is equal to velocity into time. Area is equal to velocity into time. Displacement is equal to velocity into time. Area is equal to velocity into time. Displacement is equal to velocity into time. So area is 10, displacement is 10. Can I say area is equal to displacement? Yes ma'am, you can. So area is V into T, displacement is V into T. That means I can write that displacement. Okay, let me write it in a better manner. So that means displacement can be or is actually equal to area of which graph? VT graph. Understood how we find out all these things? Now see carefully. Displacement is equal to area of VT graph. So three things we studied. Slope of VT graph. Then we studied, now slope of VT graph gave us what? Slope of VT graph gave us acceleration. It gave us acceleration. It gives us beta acceleration. So slope of VT graph gives you acceleration. Remember this thing. Next beta, again slope of, but which graph? Slope of DT graph. Now ma'am, which slope of displacement time graph. Slope of displacement time graph. Slope of displacement time graph gave you what? Velocity. Slope of displacement time graph beta, that gave you velocity. Okay, and area of displacement time graph. Area, okay, let me change the color. Area of velocity time graph. It gave you beta what? It gave you length into breadth. V into T. V into T is what? Displacement. I know I know it can be a little bit hard in the starting, but we all are preparing for a bigger motive, not just 9th and 10th, right? So we have to give a little extra effort. Just go through this. If you don't understand, go through this whole slide again, this whole slide again, this whole slide again. Everything will be available in the description. Go check that out. Okay, now let's move on to some very important questions. Some very important questions on these, and these questions are beta previous year questions of NEET and JEE. So remember, you can do this. The level of JEE is hard, I know, but why do we say it starts from 9th and 10th? Because of these kind of questions. So these questions, if you already know these questions from 9th and 10th, who will try to stop you in +1 and +2? Nobody can. If you say that I want to crack JEE, I want to crack NEET, then you will crack it. Nobody can stop you, and you have taken the decision of studying it before everybody else, or to showing it every day. If you are the one who is watching the second lecture and is being consistent, let me know. I want to know my students. I want to know my bright students who are actually here to win. Okay, now the question, look at this very carefully. Okay, the velocity time graph of a body moving in a straight line is shown in the figure. Okay, I just wrote half of the question. Okay, but the question was, beta, find the ratio of displacement divided by distance. Find the ratio of displacement to distance. Try doing it. Let me have my tea. My throat is really bad, so I get a little comfort I can. Okay, try this question. Try to find the displacement. This is a velocity time graph. This is beta a velocity and this is time graph. Now we just studied how to find displacement from velocity time graph. How to find displacement from velocity time graph. Think about it. Let me know if it is done. Let me know the answer in the comment section with the timestamp. Okay. Now beta, let's see. How do we do it? We say that velocity is equal to area. Okay, not velocity, displacement. Displacement is equal to area under velocity time graph. Okay. I write it like this for a little speed. You can also. Okay. VT graph. Now beta, look at this carefully. What is the area? What is the area of this graph? How will we find that? Ma'am, very easy. What is the area of this is rectangle? Length into breadth. What is the length and breadth? Ma'am, okay, this was 1, 2, 3, 4, 5, 6, 7, 8. Now, tell me the area. Ma'am, length into breadth. What is the length? 0 to 1, 1 to 2. So, length is 2 and breadth is what? 0 to 2, 4, 6, 8. Breadth is 8. So, this is 16. The area of this is length into breadth, 16. How much area will this have? Ma'am, this is -2 and -4. So, this is -2 into -4. No, total 4. This is total length, right? So this is -4 into 2 to 3, 3 to 4. So this is again 2. So the area here, the area will be -8. We are just talking about direction. Okay, let's talk about direction. Don't worry. Then again, this area, ma'am, this is 0 to 4. So 4 into 4 to 5, 5 to 6. That is also 2, that is 8. Again, 8 is the area of this particular section. Then again, this, ma'am, it is only till 2. So -2 into 6 to 7, 7 to 8. Only 2 values. So 2. So its area is -4. Its area is -4. 6 to 8. 2 and down also 2. Now, one very important thing is here, that is beta, for displacement. How will you do that? You will just add all these areas, area under the curve, add all these areas. But this is in negative, and we know displacement can be negative, velocity can be negative, right? So for displacement, we will take -8 and -4. Okay, for displacement, listen to me very carefully. For displacement is area. So area of this section plus area of this section plus area of this section plus area of this section. That means what? 16 plus minus 8 because it is displacement. It also has direction. Direction is negative y-axis, right? So this will then plus 8 minus 4. Plus 8 plus minus 4. So what will be the answer? This minus 8 plus 8 cancels. 16 minus 4, 12 is the displacement. Then what will be the distance? Beta, in a distance, we don't calculate direction, right? So this minus will not be there. We'll simply say, see, if I go this, right, plus 2 meters. And if I come back, minus 2 meters. Displacement is 0. But distance is what? Plus 2 meters, plus 2 meters, 4 meters. Right? So I won't take the negative sign. So this will simply be 16 plus 8 plus 8 plus 4. So this will simply be what? 16, 16, 32, 36. So what is the ratio we have to find? Displacement divided by distance. That is what? 12 divided by 36, 1 by 3. So the ratio will be 1:3. That will be your answer. Easy? Understood? Do you think it's JE level? It's not 9th level, I'll say. It's not 9th level, but it's also not that hard that you have to wait 2 years to do this kind of question. You have to wait 2 years to actually start your JEE preparation. Is this question that hard? No, ma'am, simply it included the area under VT graph. The area under VT graph, to find the displacement we take negative units, to find the distance we take positive units. That's the only difference, right? Okay, let's see another question on your screens. Okay, if the velocity time graph has the shape AMB, this is A, this is M, and this is your B, what would be the shape of corresponding acceleration time graph? Ma'am, what is this question, ma'am? Ma'am, what is this question? Okay, wait. Now, carefully study this. Now, see, when we studied about graphs of velocity time. Sorry. Okay. So, beta, we have uniform motion, constant velocity. We have non-uniform motion, not so constant velocity, changing velocity. Now, come to this. When we talked about this velocity time graph, it is a uniform acceleration graph. That means velocity is changing, but see, acceleration, it is not changing. It is a straight line. So when my velocity is increasing, acceleration is a straight line. You can see that when my velocity is increasing, acceleration is a straight line. Now apply this exact concept to this particular question. Now beta, look at this. This is my velocity. So velocity is decreasing. Velocity is decreasing, but it is decreasing in a straight line. It is decreasing in a straight line. So my acceleration graph will be what? A simple straight line. So this will be my acceleration time graph. Okay, let's not do that. One more thing, understand this. See beta, this is coming down. This is going in a negative direction. This is decreasing. So here, acceleration, first acceleration, velocity is 0. Final velocity is minus 4 meter per second. So what will be the acceleration? It is a negative acceleration. Why? Because this is decreasing. So it will be negative acceleration. Your vehicle, you are driving it at 4 meter per second. Now you are stopping. So your final velocity is 0. Initial velocity was 4. Final is 0. Let's not write 0. Let's say 4 and 0 at this moment. Let's say this is 0 and here you had 4 meter per second. Okay, so earlier the velocity was 4, now the velocity is 0. So velocity is decreasing, so acceleration will be negative. See, velocity is decreasing, that means acceleration is negative. So you will draw this acceleration below the x-axis. This will be your x-axis, this will be your y-axis, right? Now below the x-axis we all have negative values. So this will be below the x-axis and this beta will be your acceleration for this particular point. This particular ray AM, this will be AM. Velocity is decreasing, but it's a straight line. Since it is a straight line, velocity is constant. When velocity is constant, acceleration is not changing. Acceleration, when velocity, velocity is not constant. Sorry, my mistake. Velocity is decreasing, but it is a uniform acceleration. That means velocity is decreasing in a uniform manner. Velocity is decreasing, equal velocity is decreasing in equal interval of time. Okay, that means it's a uniform acceleration. For uniform acceleration, acceleration is constant. Acceleration is constant. Understood? Wait, let me go back to this again and tell you here. Okay, see, velocity is increasing, acceleration is constant. We just saw through this, right? Every time acceleration is constant. Even though velocity was increasing, at 0 it was here, at 1 second it was 10, at 2 seconds it was 20, 3 seconds it was 30. So velocity is increasing, but acceleration remained the same. Acceleration remained the same, right? That's the same concept we used here, but the only difference is velocity is downward direction. So acceleration will be negative. Okay, now see, velocity is again increasing. So from 0 it went back to 4 meter per second. So now acceleration is increasing, velocity is increasing. Velocity is increasing, sorry for that. Velocity is increasing, okay, but it is increasing at equal interval of time, right? So acceleration will be constant, but at this point it will be in the positive x-axis. It will be in the positive x-axis, and that is your acceleration time graph. This is your acceleration time graph. Understood? This is your acceleration time graph. What happens? Velocity is decreasing, acceleration is negative. Velocity is increasing, that means acceleration will be positive. Of course, velocity increasing, acceleration is positive. Velocity is decreasing, acceleration is negative. That is retardation. Correct? What will be the graph? Now, this is a uniform acceleration graph. So velocity is decreasing uniformly, that means acceleration is constant. Velocity is, first velocity was 4 meter per second at 1 second, then 2 meter per second at 2 seconds, 3 meter per second at 2 seconds, 0 meter per second at 2 seconds, and 0 second. Okay, what did I do? Wait, let me go back to it, circle to it. Okay, erase that. Now start from here. Beta, velocity was 4 meter per second at 0 second. Then velocity was 3 meter per second. Here, velocity was 3 meter per second at 2 seconds. Okay, so that means, let's look at it like this. That means you have this graph of velocity, you have this graph of time. Now, beta, first your velocity was 4 meter per second at 0 second. Okay, then at 1 second, 2 second, 3 second, 4 second. Okay, now look at this. First your velocity was 4 meter per second at 0 second. Then your velocity became 3 meter per second at 1 second. So now your velocity is this. Then your velocity became 2 meter per second at 2 second. Then velocity became 1 meter per second at 3 second. So what is happening? In 1 second, 4 to 3. In 1 to 2 second, 3 to 2. Okay. So 1 meter per second change is 1 meter per second in 1 second. Again 2 to 1. 1 meter per second of change in velocity in another 1 second. So this is equal amount of velocity is changing in equal interval of time. That means acceleration will be constant. It will be constant, and since velocity is decreasing, acceleration will be negative value. And similarly from here, in 1 second it is going up, in another 1 second it is again going up, in another 1 second it is again going up. So again equal amount of velocity is changing in equal interval of time. So that means acceleration is again constant, but now it is positive. Okay, take some time to understand this, it's fine. Just try to learn it from the scratch. Okay, so that is your final answer, A to M and then M to B. This will be the graph of acceleration with respect to time, with respect to this particular graph, velocity time graph. Done? Okay, let's go to the last question, beta, and on your screens we have this very interesting question. The question says, the position time graph for two students A and B returning from the school to their homes. Okay, now we have some values. A lives closer to B. Okay, so we need to see the position. B lives closer to C. Again, we need to analyze the position. I'm just showing what do we need to analyze. A takes lesser time. So here we need to analyze time. A travels faster than B. Okay, we need to analyze velocity. Here also velocity. B travels faster than A. Let's look at it. Now beta, look at this very carefully. This is your time. This is your position. Now this is, let's say, time 1. This is t1. And for your convenience, let's just take this 4 seconds. And this is from this 0 to yes. So it reaches home till here, right? So this will be T2, that will be 10 seconds. Let's take, okay? So this will be B. So this arrow goes till B. So that means B reaches home. This is the home, okay? This is the home. This is B's home and this is A's home. So this is your school. Now beta, from school to A, B home, it reaches in T1 seconds. That is 4 seconds. For A, it goes from school to home in T2 seconds. Now see one thing very clearly in this. Beta, the A graph starts from 0. That means I turned on the stopwatch and I asked A and B to go home. A started immediately. It ran towards its home. But B is like, let me wait for some time. So after A reached here, B started from the 0. So B is still at school, A reached halfway. Now B is like, now I will start to go home. Okay, so that what happens. Now look at this carefully. This is what X. So this is the distance of from school to home. This is the time that they are taking from school to reaching home. This is the distance between their school and home. So this distance is the distance of B. B is home from school. So let's call this as X1 and let's say this is what, 10 meters. Okay, and A, this is the distance of A's home from school, and let's take this as 4 meters. So look at this very carefully. From school to A's home, this is A and it is his home. A takes how much time? A takes 10 seconds to reach his home, but his home is only 4 meters away. Understood the graph? A takes 10 seconds to reach home, but his home is only 4 meters away. B, however, B takes how much time, beta? See, B don't take T1 seconds. We don't take T1 seconds. It take this much. It started at this. It started at 3 seconds. Let's say this is 3 seconds. It started at 3 seconds and in the 4th second it reached home. So technically not possible, but it is only taking 1 second to reach home when it is distance of B's home from school is 10 meters. It is only taking 1 second. A home is only 4 meters away, but it is taking 10 seconds. Understand the graph? Understand the graph? That means time of A time that A takes to reach home, listen to me carefully, time that this first student takes to reach home is more than the time that this B student make. This is the time that A students take to reach home. This is the time 0 to 10 seconds that A student takes to reach home. But 3 seconds to 4 seconds, B takes only 1 second. B takes only 1 second, A takes 10 seconds. So who takes more time? A takes more time, B takes lesser time. So A takes lesser time to reach home. That is not true. B, okay, that is not true. B takes more time. That's not an option here, right? So that is one thing done. Understood? A lives closer to school. Now this is the distance. This is the distance of A. This is the distance of B. This is 4 meters. This is 10 meters. So obviously A lives closer. A lives closer to the school. This is true. B lives closer to the school. This is not true. So A is true, right? Then beta, D, A travels faster than B. How will we see that? Ma'am, for faster we need to see velocity. Velocity is distance or displacement upon time. So let's see for A. For A, velocity is what? Displacement upon time. How much displacement did A see? A was 4 meters away. So its displacement is 4 meters and it took 10 seconds 10 seconds to reach home. So the time is 10 seconds. For B, ma'am, however, the distance was what? Distance was 10 meter. For B, distance was 10 meter. Okay, distance was 10 meter and it only took 3 to 4 seconds. Only 1 second it took. So the velocity of B is what? 10 meter per second, and the velocity of A is what? 0.4 meter per second. So whose velocity is faster? Whose velocity is more? 10. So the whose velocity is more, that person will reach home faster. So B travels faster. B velocity is 10 meter per second. A velocity is only 0.4 meter per second. So B travels faster. So what's the correct option? A and E. So A and E is the correct option. Understood? So this question tells you how to read the graph. This question tells you what? How to read the graph. Okay, and these questions were JEE questions, NEET questions. So imagine you are already done with JEE and NEET questions, and there are so many questions out there. I will come up with those as well. Don't worry. Until then, just do this. Chill, relax and do this. No need to worry about so many questions, doing all the things. We just want our concept to be crisp. Okay, so that when we go and enter in our 11th class, we don't need to do this. We can directly jump to a little higher questions. Okay, we can directly understand the concept and understand a little higher level questions. Okay, that's it, beta. That's it for this video. I'll meet you in the next one. Prepare for your boards, your 9th class exams as well. But we have this very important goal of reaching IITs, of reaching top medical colleges of India, right? So that dream starts right now, and you have to start the practice right now. Okay, because we want to be ahead. It is a competition. Take it in your mind that I want to score better than everyone in this whole country. Yes, strive for AIR 1 and then only you will be getting AIR 1 or at least closer to it. That's our goal, and I'll see you in the next video. Until then, take care. Bye bye.